Welcome to Earth Science, everybody. Good morning. We're going to talk about, in these two sections of notes, which I'll do as two separate videos, how do we know that we revolve? How do we know that we rotate? How do we know that the planet is doing these things? I talked about this on the very first day of school. As you sat there in those seats, I said, right now you're heading towards that wall at a terrifying speed. And that's happening because the Earth is spinning. And simultaneously, the Earth is going around the sun at a terrifying speed. And we're going to figure both of those out today. And actually, simultaneously, the sun's going around the center of the galaxy, but we're not going to figure that out today. We're going to pretend that's sitting still. So let's figure out how quickly we revolve, which this part I'm going to say is not a number you would have to memorize. This is kind of just cool trivia, if you consider it that. So, how could we do this, though? Which I do think is kind of an interesting way to think about Earth science. How could we figure out how fast we're going? We would need the circumference of this, and then we would need how much time it takes, and then we're good to go. So, how do we figure out the circumference of Earth's orbit? Here's another diagram I'm going to use today. How do we figure out basically how long that path is? That's not in the reference tables, but what is in the reference tables is how far from the sun we are. Which, if you're clever, you would know that right there. If this is a circle, which again we know it's not, we know it's an ellipse, but we're going to call it a circle because it's so close. If I know that distance, I really know the radius of a circle. And if I know the radius, could I figure out the circumference? Yes. If you look it up on the internet, it's 2 pi r. So 2 times pi times the radius will be the circumference. So let's do it. 2 pi r. So I need 2 times pi times the radius, which is, for Earth, 149.6 million kilometers. I'm actually going to type that. 149, comma, 149,600,000 kilometers. So it's 2 times that times pi. So what's that going to give us? 2 times 149,600,000,000. All right, all of this equals 939, comma, 488, comma, 000. So that's the how long the trip is that the Earth has to take every year. That many kilometers. Over how many hours? Well, do you know how long it takes to do that trip once? Hopefully. That takes a year, but we got to get that down to hours. So 1 year is 365 days times 24 hours, which is 8,760 hours. So throw those two in a calculator, and we have ourselves a rate. I guess I did it in kilometers per hour, not miles per hour. It's still going to be a terrifying number. 939, 488, 000 divided by 8760. So we're going about 107 247 and a decimal, which I'll ignore because that's fast enough. We're going about that many kilometers per hour. So that's Holland. That's the speed at which the planet is traveling through space around the sun. Scary. Now, again, I'm not going to say any of this is like critical for you making it through this. Okay. What occasionally gets asked, not a terribly like frequent question, but it's one that happens sometimes, is what's the rate in degrees per hour? So you can either memorize this or you can just use your noggin and think about it if this question ever pops up. Do you know how many degrees it would have to do for one full loop? Actually, you know what? This doesn't get asked like this. It gets asked in degrees per day, which is even easier. So do you know how many degrees are in a full circle? Hopefully we do. It's 360 degrees to do a full circle. And how long does it take to do that once for the planet to go all the way around the sun? It takes 365 days. So again, you can memorize this, or you could just like be able to work that out in your head as you do this. And really, if you got, it's about the same number on top as on bottom. It's close. And if you have the same number on top, same number on bottom, it's one, right? I'll do it, but it's going to be, yeah, it's 0.987. So it's really close. And this is what the Regents will ask. It's really close. You ever see this like wavy equal sign for about? It's about a degree per day. So that's fair game for questions. Although, again, not super often are you going to see that one. All right. What they will ask a lot, and what the classwork that you're going to do at the end of this note set is going to come at you with, is this idea right here, 1.1G, and this is out of the standards. Seasonal constellations and the apparent positions of constellations provide evidence of Earth's revolution. How did we figure out that we're actually taking this trip around the sun? So what we got here, I think actually this, I wish I just used this diagram. Now that I found it, it's better. At night, you can look out. Let me try to use the pen here. Yep, you can look this way and you can see stars. So at night in this position, you might be able to see these constellations here. But what are the chances you're going to be able to see the ones that are way over here? Where would you have to look? It's during the day, you'd have to look through the sun to see them. The bad part is that during the day, the sun's out and you can't see stars. So you really don't stand a chance of seeing ones that are in the opposite part of the solar system. So people started noticing this, that in certain seasons, there's some constellations that are up, and in other seasons there's different constellations that are up. Excuse me. So we'll go back to this one. May 21st, you can see Scorpio. Now these do not match if you're falling under the spell of astrology. The horoscopes and all that, you might notice these don't match. Don't worry about that, because that is like a pseudoscience. We can talk about why it is later. But in May, you might be able to see this constellation. But you're not going to be able to look through the sun to see one on the opposite side of the solar system. So what was eventually realized is that as we travel around, wherever we are at night, which is looking away from the sun, points to different constellations. There's some constellations you can see all year round. If you've ever noticed the Big Dipper, you can see that no matter what day it is, because those are like up above the planet where it sits. So no matter what, when it's nighttime, you can look up and see those. But it's the ones where you're looking out that would change throughout the course of the year. So May you can see that, but not that. And then come over to November, you'd be able to see Taurus, but not Scorpio. There's the basis for that astrology nonsense too, because Scorpio, the sun are in line, and that apparently affects your demeanor. I don't know. So anyway, listen, it's a tricky kind of idea. This is another situation where you've got to be able to picture yourself on Earth in a solar system, even though we're in space looking down on this. But really, they're very easy questions. All it will be, maybe highlight with me here, if we can turn this off. Oh, that's why. Um, that seasonal constellations, seasonal changes, didn't change my transparency. Sorry, folks. Seasonal changes go with the constellations. That's the evidence. Let's remember what we did towards the beginning of the year with redshift and cosmic background radiation. If you remember, like beating on that, beating on that, beating on that, it really came down to the questions being redshift, expanding universe, evidence of the Big Bang. Right? That's it. We didn't really need to understand the nature of the Big Bang. It was just what's the evidence. These are going to be the same types of questions, and you'll see them when you try the classwork. Seasonal constellations show us that we revolve. That's it. Okay. So don't worry about that. Loosely stick that in your head somewhere, or at least like remember how to figure out how to do it. And maybe we'll try to do like a classroom version of this where we put the sun in the middle and we see what it looks like as you work around. Because it's a tricky idea to picture. But again, at the end of the day, the questions are really very simple. Seasonal constellations show us that we revolve. That's it. All right. Good job, folks. Sorry for all the tinkering over there. Thanks for sticking with me. Good luck.